Hello, this is Mr. Stansbury. I'm going to take you through the 15H notes on arguments with three propositions. At the end of this, you should be able to say, I can determine the validity of three logical arguments by using a truth table. All right, so let's get right into it. Example 13 from page 513 says, let's say P is 2x plus 5 equals 13, Q is 2x equals 8, and then R is x equals 4. Use the chain rule to show that P implies Q, so this implies this. Q implies R, Q implies R, so therefore P has to imply R, so this has to be this. So if you'll notice, this is just a simple algebra problem that is simplified. First subtract 5 from both sides to get 2x equals 8, and then divide both sides by 2 to get x equals 4. So it's just a simple algebra problem. We're just going to use that algebra problem to try to show the chain rule, and then we want to check and see if this is logically correct. Okay? So to see if this is valid or not. So we have three pieces that we're going to look at here. So three arguments. So what we want to do is we want to make a Mamahana truth table here, okay, that includes P, Q, and R. All right, so remember, if we're doing this here, we want to start with the last argument here and do true, false, all the way down. True, false, true, false, and then the next one is true, true, false, false, all the way down. And then this last one here is 4 trues and then 4 falses. And the reason why we do this, again, is so that we make sure that we hit all possibilities. So we got all true, 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 false, true, false, true. Every single possible combination of true and false for these three is covered if you do this little pattern. Okay, so first thing we're going to want to do is P implies Q. All right, so P implies Q. So remember that when we're doing implications, the only thing that's going to make it false, so maybe we'll even write ourselves a rule, the only thing that's going to make it false is if we start with true and then we go to, I won't do that, let's see, we start with true and then we go to false. So that means you have the ingredients but you can't make the best cookies. Okay, so this is the only one that's false, everything else is true. So P to Q, so just these two. So true, true is true. Let's just look for the true, false. True, true is okay, true, false, that one's false. True, false, that one's false. False, 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 false. So everything else has got to be true. Okay, so that's what we're looking for. It starts with true. The first one's true, the second one's false. That's the only one that ends up being false. Okay, let's do Q implies R. So we got Q implies R. So again, we're going to look for the true, Q being true and R being false. So here's Q and R. True, true is okay. True, false, that's a false. False is okay. True, true is okay. True, false, that one's false. And the rest of these are going to be trues. Okay. Okay, I hope you're following me here. Let's see, let's take a little video break, shall we?
I'm trying to get smart. I've been watching Nova. You seen that show? They had a thing a couple of weeks ago about string theory. I started watching that at 8 p.m. and at 8:03, my brain exploded. They said string theory is the stuff that the physicists are now figuring out that Albert Einstein was not able to nail down in his theories. Something, well, if Albert Einstein didn't understand it, me on a couch with a bag of potato chips don't have a shot. Oh, I see what they're talking about. Yeah, you gotta incorporate gravity. I was wondering why he didn't do that.
All right. Let's see. We did P implies Q. Q implies R. So now we want to do these two together. So we want to do P implies Q and, Q implies R. Okay, so we want to do these two together. So it's got to be P implies Q and Q implies R. So the only way that's going to work is if they are both, since it's and, they both have to be true. So that one's true. True, false, that would be false. False, true is false. False, true is false. True, true, there's our other true. True, false does not work. True, true works. True, true works. Okay, so that's our and. So that's these two together. Now we got to figure out if that is the same as our P implies R. So that's one thing that we haven't done yet, is P implies R. Okay, so again, we're looking for the only one that's going to be false is if it starts at true and it ends with false. So P and R. So this column and this column here. True, true is okay. True, false, that's a false. True, true is okay. True, false, that's a false. False, true, false. All the rest of those start with false, so the rest of these are going to be true. Okay, so excuse me, last thing, we want to figure out if we have this group here, which is this one. P, I don't think I'm in enough room, but I'm going to give it a shot. P implies Q, and Q implies R. And then we want to know if that whole thing implies P implies R. Yeah, sorry. So then we've got P implies R. All right, so does this one here imply this one here? Okay, so again, we're just looking for the true, false. True, true is okay. False, 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 true. False, false. True, true. False, true. True, true. True, true. We don't have any true falses in here anyway, just double checking. So this is going to be, these are going to be all true. Okay, and since these are all true, that makes this a tautology, which means therefore this is a valid argument. Okay, so logically this is a valid argument. Okay, and we can also see that by saying, we can figure out, hey, if 2x plus 5 equals 13, we'll eventually figure out that x equals 4. Okay, that's all there is for this here. If you have any questions, please ask. Thanks.